this problem looks a little bit different. Oh, that's because it is different. The first thing I notice about this problem is both these guys have some amount of y's in them, and there's also, both these coefficients are even. So I actually have a greatest common factor to pull out first. What goes into 32 and to 2? The GCF of these coefficients is 2, and both these terms have a y cubed. So actually I'm going to kick this problem off by pulling out a 2y cubed and then kind of using my reverse distributive property. So if I wanted to get a 32y cubed and I had a 2y cubed on the outside, I would need a 16 to get up to 32. And no y's. That's it. Right now, this times this is going to give me that 32y cubed. Then I have to get this term back. So I pulled the 2 out, so I don't need to put any 2's in there. I will need a v to the 4th in there, but I will not need any kind of to put any extra y's in there because I pulled that out as well. And then this is subtraction, so that's subtraction. So this is not a bad start. But then I'm realizing something else. I'm realizing that this is, in a way, it's a difference of perfect squares. Like 16 definitely is a perfect square. That subtraction sign's got me thinking. And there is something I can square to get v to the 4th. V to the 4th is like a v squared squared. So this problem then is going to become something like, I got that 2y cubed that I had. And then this part I'll treat like a difference of perfect squares. So what do I square to get 16? 4, of course. So I'm going to have a 4 and a 4. And then this v to the 4th, what do I square to get v to the 4th? V squared. So I'll have a v squared and another v squared. One's plus, one's minus. But oh my goodness, wait just a hot second. What's going on over here? I got another subtraction, another perfect square, and another perfect square. So this is going to factor even further. Oh my gosh. So all the rest of this stuff, can't do anything with this. That plus sign, forget it. It makes it not factorable. So this is going to be copied down. That 2y cubed just by itself. This 4 plus v squared, I can't do jack squat with that. But this 4 minus v squared, 4 is a perfect square. I could do 2 and 2. V squared could be v and v. One's plus, one's minus. That will be my final answer to that problem. So just kind of keep a lookout for those difference of perfect squares because they're easy, but they like to sucker punch you with these ones that break down, and they break down further, and they break down further. So you really want to be aware of numbers like 1 and 4 and 9 and 16 and 25 and 36, and basically all the perfect squares up to like 100, up to 10 times 10, just so when you see them, you recognize them. Good luck with these. Be patient with yourself.